We're going to use that interactive map from the earth.newellschool net operation. And what we have on the left is El Nino characteristic. In the middle is the neutral, or what we the traditional, kind of what we think is as normal conditions. And on the right would be La Niña. And so what you can definitely tell is some differences in terms of the colors. First off, let's start off with El Nino. We see the warmest sea surface temperatures. That's what's being shown here. Sea surface temperatures with the currents moving. The warmest temperatures are actually here in the middle of the Pacific. Whereas in a neutral or normal conditions, we'll see the warmer waters over here. And then in La Nina, you can see we have the warmest waters over here. And in that middle area, it's definitely cooler. And in the eastern part of the Pacific, we have our coolest temperatures. You can see how the temperatures are much different. And so essentially during El Nino, what's happening is the warmer sea surface temperatures are moving towards the east, from the west towards the east, so essentially moving towards central and eastern Pacific Ocean areas, away from the western Pacific Ocean. Neutral, common. This is not perfectly neutral since this is May, these are in October, but let's just kind of work with the idea of neutral conditions here, kind of average. Whereas during La Nina, you can see very cool temperatures. And even further, now let's look at the currents, in which direction the currents are moving. And so in El Nino, if I zoom in and look at the currents, which direction are they moving, we can see this predominant pattern. And so this is very characteristic of El Nino. The Pacific current here along the equator moves from west to east. So essentially bringing that warm water from this particular area to the east, to the central Pacific. Now let's take a look at the currents during La Nina. And typical of this pattern, we see the opposite effect. So La Nina, yeah, we do have some west to east movement, but look what's going on here. Look how much this cool Pacific water just off the coast of Central and South America, how it's cooler, and then also now we have that east to west pattern, and so a western movement of the current during La Nina, where in our neutral characteristic, our neutral conditions, a little bit of kind of here, there. Once again, this is the doldrums. This is very neutral, very common characteristic we see here in between in El Nino and La Nina period. Another way to showcase this is looking at another variable, sea surface temperature anomaly. So I'm going to go ahead and look at each one. And this very clearly shows how abnormal temperatures are during El Nino compared to neutral. And so during El Nino, the eastern and central Pacific along the equator, much warmer temperatures. Whereas during La Nina, those same areas have cooler temperatures. So essentially what's happening is now the warm water is being moved to the western part of the Pacific Ocean, here in Southeast Asia, Indonesia, in these island countries, Philippines, Malaysia. So what this has shown is essentially the differences between El Nino and La Nina, but also their fundamental characteristic, in which during El Nino, warm water is being moved from the western part of the Pacific to the east, to central Pacific, whereas in La Nina, the opposite is happening, in which water is being moved from the east to the west. Now let's take this one step higher. So what we have here is we have a characteristic of high pressure areas and low pressure areas. We know this from earlier. We associate low pressure areas with warmer conditions and higher pressure areas with cooler conditions. And so in a normal condition, the normal situation, the normal pattern here in the Pacific Ocean is we have a low pressure here over Southeast Asia. And this is logical. This here is because we have the warmest temperatures, and so we have convection and convergence, and so that warm air is going to rise, and as it rises, of course, it's going to condense and fall back down as rain. We know this. Why am I saying, well, that's so obvious? Because this is where all the world's rainforests, much of them are located in this particular area, a very wet part of the world. And so here, this warm air rises, and then as it rises, we kind of have to imagine here we're going not up in terms of latitude, but up in the altitude. So I'm going up. And so as it rises, it cools, and it moves easterly. It moves towards this area where it then descends. And we know air that descends, it's going to descend, it's going to be cool, it's going to be dry, and we associate that with a high pressure. And so over here on this particular part of the world, we have some of the driest areas of the world, the driest deserts of the world over here in this particular part of South America, this coastal part here along the Pacific. And so this is the normal pattern. And so a high then feeds that then low pressure, and so we have the winds coming this way along, bringing that current, and so this is the normal pattern. During La Niña, essentially what it is it's a extreming of normal conditions. This is more normal to the extreme. And so now in La Niña, that high pressure is even more pronounced, and then we have even a more pronounced low pressure. And so during a La Niña event, what happens is the dry gets even drier, and the wet gets even wetter. And so we have a high pressure that becomes even more pronounced, and a low pressure that becomes even more. And so we have rainier periods during a La Niña event here in Southeast Asia. Now let's go to El Niño. And so El Niño, we see a movement. And so now the warmest temperatures are here. So that low pressure area is actually over here. And so during a El Niño event, Southeast Asia actually has very dry conditions. And so Southeast Asia, because that low pressure's moved over here, this area that's traditionally a rainforest that gets a heavy amounts of rain, suddenly now they have large dry spells. They have drought periods. And so during that period of time, we have reduced precipitation, and as that low pressure area moves to the east. And so essentially then what happens is now we have more low pressure activity over here. And so now over here in the extreme western part of South America, that driest desert of the world I told you about earlier, they actually get heavy amounts of rain. And so during an El Niño event, they get this rainfall that they might not get for another few years. And so once in a 5-year period, they'll actually get a rainfall, and that's during an El Niño event. And it all relates to just essentially the movement of a low pressure area, essentially the movement of where the sea surface temperatures are the warmest. Now let's take this one step higher. So although we have a very minimal change, and we're not talking 10, 15 degrees and change in terms of the water temperature, sea surface temperature. We're talking, a degree Celsius, maybe 2. So very minimal amounts. What that though results in is a shift though in the jet stream. So it's amazing how something at the surface can end up influencing what's happening way up above. And so what I'm going to do is I'm going to move this to air, and then I'm going to select 250 hectopascals, and that's going to be our proxy. We're going to use that for the jet stream to try to showcase how the jet stream changes during these different events and how that relates to changing weather patterns that we find here in Northern America and Indiana. So in the middle I have the normal conditions. Not going to worry too much about that. We're just going to focus in on La Niña and El Niño and how that brings either wetter or drier conditions for different parts of the region. All right, and so here is La Niña. And so what we see here is the jet stream has moved more northerly, and this is very typical of La Niña. And so we have more of a northern shift in this. And so what that means is we're going to get more wetter conditions there in the northern part of the United States. Once again, we think of the jet stream as steering below it the mid-latitude cyclonic systems, the low-pressure areas. Those areas bring with it precipitation, bring with it cloud cover. And so we think about that area is going to be up here more in a northern pattern, Whereas we see during El Nino over here, the pattern shifts. And we see the pattern shifting to a more southerly pattern. So the jet stream kind of has more of its production. So now the mid-latitude cyclonic systems, those low-pressure areas, those areas with precipitation, are going to be more in the southern part of the United States. And so we get a wetter period in the southern part of the United States during this El Nino event.